Calculus Kids, this is Dr. Callahan with week 12 Thursday. How are you guys doing? Go ahead and pause the video and answer the following three questions. All right, so let's go ahead and take a look at the guided notes for today. So your guided notes is going to be in your week. Actually, it's going to be separate from that. So you have a separate piece of paper that will be handing out. If you're at home and you don't have access to this, you're welcome to just copy the work down. But essentially looks like this. Yesterday, I actually gave this to you guys where we talked about the combination of a disc method, washer method, and then of course the cross-section method. We did the first example yesterday. That was actually the one that we did in class. If you missed that, you're welcome to watch the video for week 12 Wednesday to get kind of caught up. Today, this is going to be the third day of cross sections, and we're going to continue on with examples 2, 3, and 4. So before I go ahead and get started with that, I would like you guys to go ahead and the difference here between the disc method, the washer method, and then as you get closer into the cross section method, specifically look at the differences of how the formula is set up. Look at when it's appropriate to have the upper and lower bound x, when it's y, when do you have dx and dy, when you solve for y, when you solve for x, and just make sure you're well acquainted with that. Next, I would like you guys to take a look at the formula for the cross section itself. If it's a square, it's base squared. Take a look at the following. Those are the 6 different shapes that you could possibly have. All right, so with that said, this is the second part of it, which we'll talk about a little bit later. But let's go ahead and jump right in and get started with this one. Example 2. It says, find the volume of a solid if the base is bounded by the curve y equals x squared, so that is a parabola, and the line y equals 4. And the cross section is an isosceles right triangle whose hypotenuse lie on the base and are parallel to the x-axis. All right, so let's go ahead and draw this one. So here's my grid. My parabola looks something like this. Y equals x squared. And the line y equals 4. And the cross section are isosceles right triangles whose hypotenuse lie on the base and is parallel to the x-axis. So here is the x-axis right here. And so your rectangle is going to be a horizontal shape like this. And it's parallel to the x-axis. And in this situation, you are going to visualize this rotating. And so ask yourself specifically, which direction is it going to be rotating? And then also, are you going to be solving for y or x? So then as we're looking at this, you have the isosceles right triangle area is 1/4 base squared. And then of course, given the fact that your base is a horizontal line, you're going to be using this equation right here where everything is going to be solved in terms of for x, in terms of y. And so with that said, let's go ahead and try to do that. If I were to solving for this one for x, I will have x equals the square root of y. Plus or minus the square root of y. So that the right side over here, x is equal to a positive square root of y. And the left side here is going to be x equals a negative square root of y. Okay, so let's go and find the base. Just remember that your area is going to be 1/4 base squared. So your base is going to be right minus left because of the horizontal base. And so if it's going to be right, the right side is square root of y minus the left, which is a negative square root of y. So that's just going to be 2 square root y for your base. Your volume in this situation is going to be from y1 to y2. And if you take a look at this right here, it is starting at y equals 0, and it is going all the way up over here, which is the green line, and this green line here is y equals 4. So it's going from 0 to 4. All right, so then looking at this, I have 0 to 4, and then it's going to be the area squared dy. So let's go ahead and substitute everything in. Volume equals 0 to 4. Your area is going to be 1/4 base squared. So 1/4. Your base is 2 square root y. If I square that, it is going to be a 4 times y. So then if I evaluate this, it's going to give me just a y. Now let's go ahead and integrate it. 1/2 y squared from 0 to 4. Plug in your upper bound, you're going to have 1/2 times 16, which is just 8, minus 0. So your answer is just 8 unit. And that is your volume for number 2. Let's take a look at number 3. For number 3, find the volume of a solid where base is bound by y squared, which is very similar. Except this time you have a semicircle and the base are perpendicular to the y-axis. So with this one, you have a semicircle. So let's first draw the problem. Y equals x squared. Y equals 4. Okay, so here is the y-axis, right here, going up and down. If it's perpendicular to that, then your rectangle has to be horizontal, like this. And as we determined from the last one, x was equal to positive square root of y, x equals negative square root of y. And if you look at the semicircle, the area for that is going to be, so going back to the beginning of your equation, semicircle is going to be pi divided by 8 times base squared. And then also ask yourself, am I going to use the first equation or do I use the second equation? And if it's the second equation, how do I know that? All right, well, given the fact that your base is horizontal, it's going to be the second equation again. Remember the semicircle, your area is going to be pi over 8 base squared. So let's find the base. So your base is going to be right minus left. So that's just going to be square root of y minus the negative square root of y. And again, it is 2 square root y. So plugging this into your area is pi over 8 base squared, which is 4y, which is the same thing as pi over 2y. Now let's go ahead and plug this into the formula. Your formula is volume is from 0 to 4. It is going to be the area of the cross section, and the area of the cross section is pi over 8y dy. This is a constant, so I can just move it out. So I have pi over 8. Evaluate the y, which is going to give you 1/2 y squared from 0 to 4. And so let's go ahead and plug this in. My upper bound is going to be 4 times 4 is 16 divided by 2, which is 8. Minus my lower bound is just going to be 0. So it's going to be 8. Don't forget your constant here, pi over 8 unit cubed. Listen, let me see if it's correct. Oh, I'm sorry, it's pi over 2, not pi over 8. Couldn't see that, sorry. So pi over 2, which is just be 4 pi unit cubed. And that is your answer. All right, let's take a look at example 4. With example 4, notice that's a little bit different because you now have an ln. So your function is ln x. The next one is a 1/2 x minus 1, which is just a straight line. Now, the way that the ln x looks like is if this is your x, or excuse me, your y-axis, it looks something like this. Okay, so then we can determine that this line in green is going to be your ln x. And this blue line right here will go ahead and be your one over 2x. Okay, so then it's a cross section perpendicular to the x-axis. So make sure you accentuate where the x-axis is located. If this is the x-axis and it's going to be perpendicular to that, then you know that your rectangle is going to be vertical, like that. And the cross section is isosceles right triangle. So let's go ahead and see if we can find the area or the volume of that. All right, so then let's go ahead and take a look at the base. So your base is going to be, because this is a vertical base, you're going to be looking for y equals solving everything in terms of y, solving y in terms of x. Your upper and lower bounds are on the x-axis, and your base is going to be top minus bottom. Top, it's touching the green part, which is just going to be ln x, and thank goodness because you solve for y in this situation. Okay, so it's just ln x minus the second part of the graph, which is 1 over 2x minus 1. So it's minus 1 over 2x plus 1. And then let's go ahead and plug this into this equation for the area. So your area, remember, is going to be 1 over 2 base squared. So in this situation, it's ln x minus 1/2 x plus 1 squared. So then let's go ahead and plug this into your volume. Your volume formula is going to be integral x1, x2 your intersection here is going to give you in a decimal, which is going to be 0.464, and then on top it's going to be 5.357. And so then if I go ahead and find the integral of this, I'll have 1/2 ln x minus 1 over 2x plus 1 squared dx. And then, of course, if you go ahead and evaluate this, your volume is going to end up with 0.613 unit. All right, you guys, at this point, I would like you to do a little bit more practice with this. So I would suggest that you guys go over to this paper here. You have 3 or 6 different examples, and if you guys need the answers, I have the answers right over here for you guys so you can take a look at. As always, stay safe and healthy, and I'll see you guys next time. Take care.